Hello, today we are going to present our architecture designed for 3 tiers web app hosted in Amazon Cloud. So we are going to have an overview about all the elements that we worked on to complete our architecture for this assignment. So let's start first by our VPC. So we are going to select in the menu here VPC. So let's start by our VPC. So here we can see that we created a VPC named project VPC, and we can see here all the details related to it, or just click on it to see all the details that are related to these VPC. So we can see the stage, the ID, the DNS host names, etc. Now, the second step is our subnets. So let's check our subnets that we created for this architecture. So we're gonna filter them by name and have a clear view of which VPC these subnets are associated to. So as you can see, we have 3 public subnets, then we have 9 private subnets that are created for this architecture. So the 3 public subnets here, we have public subnets 1, public subnet 2, public subnet 3. Then we have for each tier 3 subnets. As you can see here, we have 3 web private subnets. Then we have for the app tier 3 private subnets. So app private subnet 1, app private subnet 2, and app private subnet 3. Then for our DB, for the third tier, we have DB private subnet 1, DB private subnet 2, and DB private subnet 3. So all these subnets are associated to our project VPC, and we can see as well from here in which availability zone each subnet is hosted. So for example, if we go to for web private subnet 3, we have this subnet hosted in availability zone C, US East 1C. Then the same for its subnets. So from here we can see which availability zone each subnet is hosted in. Another important thing here is to check the route tables of our subnets. So we have 2 route tables. We have a public route table and we have a private route table. So the public route table here contains 3 subnets, and the private route tables contain 9 subnets. And more specifically, for this project VPC, we have 2 route tables, the public one and the private one. And for the public route table, we have more specifically the public subnets that are associated in. And for the private route table, we have 9 private subnets that are associated too. So we can to see that, we can just click on the public route table and check the subnets associations, and we can see here that, as I said, all our public subnets are associated to our public route table. Then we can do the same for our private route table, and we are going to see that all the private subnets that we created for each tier are associated in our private route table. So as we can see here, we have the 3 web private subnets that are associated to our private route table. We have as well the 3 app private subnets and the DB private subnets. All of them are associated to our private route table. So now a very important element as well that we created and we worked on for this architecture is the security groups. So we can go from here to see our security groups that we created for this architecture. So here is them. So as we can see, we have for each tier, we have a security group. We have a web tier security group, app tier security group, and the DB security group. As well, for our load balancers, we created 2 security group. One for the web load balancer security group, and the other one is the app load balancer security group. So now we are going to check our load balancers. So let's check here. We have 2 load balancers created for this architecture. We have the app load balancer and the web load balancer. So we can check all the details related to our load balancers, both of them. So here we have the DNS name of the app and the web load balancers that allow us to access to our load balancers or to our instances. Then here we can see that each load balancer covers 3 availability zones. So availability zone A, B, and C. Then both of them are active. Here is their ID. Now let's check more the details related to our load balancers. So as I said, here is the basic configuration of our app load balancer and the security group as well. But an important point as well is that we can monitor the activity of our load balancer. So here is the target response time, for example, the requests, rule evaluations. We can have a look as well on the active connection counts, a new connection count, etc. We have here as well the consumed load balancer capacity units. So there is many details that we can monitor from here regarding our app ELB activity. Now let's check if this load balancer is working properly. So we can just take the DNS as I did and paste it here and try to access. So perfect. Here we have a full access. So everything is happening as expected. So we can just load tests from here, or we can refresh as well our requests. So here is, for example, the instance hosted in availability zone B that responds to our request. So if we refresh, it's now the instance hosted in availability zone C that responds to our request. Since there are many instances that are created because that we launched many requests, and the autoscaler start triggering many instances to cover our requests. Now we are going back to check as well our web load balancer. So here is our web load balancer. The same, we can check and monitor the activity related to this web load balancer. So here is all the details and the information that we can monitor from here, and we can as well check that our web ELB is working well. So we're gonna paste again our DNS. Perfect, is working as well as expected. We can refresh just to check. So again, here is another availability zone. It was B and now it's C that responds to our requests. We can load tests as well for our web ELB, and we can load tests as well for our app ELB. Now we've seen the load balancers created for our architecture, and we are going to move now to the autoscaling group that we created. So let's check them from here. So as well, we are going to find again NAP tier autoscaling group and the web tier autoscaling group. So here is the instances created by our autoscaling groups. So we have 3 instances that are created for each tier, as we have a desired capacity here of 3, minimum capacity of 1, and a maximum capacity of 8 instances. Now we can see as well all the availability zones that are covered, but let's have a more detailed and clear view by just clicking on them. So here is the group details. Okay, here is the group details of our auto scaling group. We have the launch configuration as well that we created for to launch or create our auto scaling group. And we have the network here in the network as well. We can see that our autoscaler is covering the 3 availability zones, A, B, and C. Here is the subnet ID. So there is all the details needed to just check our auto scaling group. We can check now the activity history. We created an activity notifications first for our auto scaling group, just keep updated about the launch, termination, and the failure as well to launch and to terminate our instances. We can see from here, for example, as well, the activity history. So we have too many activity history. So here's the description of all the activities that are taken here. So there is many cancelled activities. We have successful one. So here is terminating, here is launching, and we can just turn to see all. Here is a successful launching new EC2 instance, and so on. So here is many successful as well that created, launched, and terminated many EC2 instances. So the same is applied for our web autoscaling group as well. We have the desired capacity for instances here is 3. Then we have a minimum of 1, maximum of 8, with all the information needed about our autoscaling group. So here is the availability zone that are covered in our network concerning this app autoscaling group. We can check as well the activity notification here. So we created an activity notification as well as we did for the app tier, and we have all the activity history here to check the history for our all launching and terminating instances, then the failure as well. So we can have a look here about all of the activities, the past activities, just to have a look of what's going on our architecture. Okay. So now let's have a look about our EC2 instances or running EC2 instances. So as you can see here, our autoscaler has created mini machines. So we have here an app instances, we have web instances. So here is web instances that are created by our autoscaler. So we have 1, 2, 3 web instances. Then we have here 1, 2, then 3 as well app instances that are running and created by our autoscaler. So we can have a look as well on all the instances created. So we have many terminated here, many applications or instances that are terminated, but we wanna see only the running instances. Here is the running instances, and we can add as well. So running instances. We can add as well the stopped one. So here is a clear view about the running instances. We can see as well all the information related to our instances, the key name, the security group name. So we have the app tier security group, web tier security group. We have as well here the availability zones that are hosted in that our instances are hosted in. Now we are going to check our last step in our architecture, is that we are going to try to connect. We are going to try to connect to our database, because we created a database as well. Let's have a look on it. Here is our RDS. We select it from the menu as well. So let's check our database. So we created a database identified as project VPCDB. So here is all the information related to it. Here is the summary of our database, and we have the connectivity and security informations. So the endpoints. Here is the address, that the endpoint that allow us to access to our DB, the availability zone, the VPC security group. Here is the security group. Then we can have as well the monitoring of our DB. We can monitor the activity of our DB. So here is the CPU utilization, DB connections, and all the informations regarding this database. Now we are going to just take or test if we can access from our app tier to our RDS. So let's open an app instance. Here is our app instance, and let's connect to our RDS. So as we can see, here is our RDS that we created, and we accessed to our database from our app tier, as we can see here. So I didn't fill out my endpoints and all the details and password, etc., because I was already connected to my database before, so I have not to insert my password and the username and the endpoint as well to access to my DB. But I can just connect from any app instance here. I can access to any app and just try to connect to my database, as you can see here, and I can just connect automatically to my database from my app instance. But just if we can just try to insert them, just to show you how I connect. And now it is going to redirect me directly to my database. Here is it. So now I am automatically redirected to my database after I have entered all the information access to my DB. So here is the whole architecture detailed in our Amazon cloud. So thank you for your attention, and thank you.